again, in this lesson, we're going to be continuing our series on systems of equations in applications. These applications are going to be about problems that talk about percentages, and usually percentages of investments. So let's look at the first example here. It says part of an investment, investment of $32,000 earns 7.5% annual interest, and the rest earns 9% interest. If the interest from both is $2,670, how much is invested at each rate? Okay, again, we have our question here that kind of tips us off as to what our variable should be. So I'm going to go with x. I'm going to say x is the amount invested, and then talk about some is invested at 7.5%, some is invested at 9. So let's let x be the money invested at 7.5%. And we can let y be the money invested at 9%. Great. Okay, so our first equation comes from the fact that some of it's going to the 7.5% interest, some of it's going to the 9% interest, but the amount of money we had was $32,000. So that's what x and y are. X is some going in one place and y is some going in another place, but together they must be this $32,000 that we started out with in our investment. The next part, we have to think about percentages. So if we take 7.5% and multiply it by the amount that we invest in that account, that would give us how much interest we earn. And the same for the 9%. 9% times the amount that we put in that account will give us the interest from that. So together, the amount from the 7.5 account and the 9% account is going to give us this total of $2,670. Now, we don't know the amount that went to each, but we've given ourselves variables for those. Now, if we are using percentages in our equation, we have to turn those into the decimal equivalent. So 7.5% needs to be 0.075 times the amount put into x, and for y, 0.09 y. If we take that, that's the amount earned from each account added together. That should be our $2,670. So that is our system of equations, and we are now ready to begin solving it. I'm going to go ahead and solve by doing the substitution method, and I'm going to solve this first equation for x. So I'm going to subtract y from both sides. And so x must be equal to 32,000 minus y. I'm going to go ahead and plug that into our second equation where we see x. So 0.075, I'm going to get rid of x and replace it with 32,000 minus y. Okay, we still have added 0.09 y, and that's equal to $2,670. All right, so we need to distribute our 0.075. 0.075 times 32,000 is 2,400 minus 0.075y plus 0.09y equals 2,670. Okay, we can combine like terms here. We still have our 2,400. We have a total of positive 0.015y is equal to 2,670. We'll subtract 2,400 from both sides. So we're left with 0.015y is equal to 270. And we'll divide both sides by 0.015. 0.015 on both sides. And we get that y is equal to 18,000. So that's the amount of money that we invested in the 9% at the 9% rate. So we know that x plus y is equal to 32,000. So x plus 18,000 is 32,000. And we'll subtract 18,000 from both sides. And we get that x is equal to 14,000. So that's the amount we invested in the 7.5% account. if you wanted to, you could actually plug both of these numbers into our original equation, or you could think about it. What is 7.5% of 14,000 and what is 9% of 18,000? If you find 7% of 14,000 and 7.5% of 14,000 and 9% of 18,000, add them together, you will get $2,670. So you could continue to double check by plugging the numbers into our second equation. But let's make sure we answer the question. So $14,000 was invested at 7.5%, and $18,000 was invested at 9%. And some of you might be thinking, why don't we just put it all on 9%? Isn't that better? Well, in the real world, maybe you were considering how much risk there is, and maybe it was a safer investment, but it was guaranteed 7%. You know, you have to think about some of these things when you're making investments in your life. So there might be reasons for going with a safer bet if it's, even a lower percentage. Okay, let's move on and let's look at another example here. Okay, so in this example, it says Gina invests $10,000, part at 11% interest and the rest at 8% interest. The second part of this, she earned $530 more in interest for the year from the account earning 11% than from the account earning 8% in interest. So that's going to be a little bit different than our first example, but let's start the same way. Let's let X be the money invested at 11%, and we'll let Y equal the money invested at 8%. Okay, so some of it's going to the 11%, some of it's going to the 8%. That's X and our Y's, but we know that all of the money is $10,000. So that's our first equation. Now, she earned $530 more in interest for the year from the account earning 11%. Okay, so the account earning 11%, that's our X. So that's 0.11X. The amount from the other account would be 0.08Y. When I think about where the 530 needs to go, I always think, okay, which one did she earn more in? She earned more in the 11% account. So the $530 to balance things out here would have to go on the side of the 0.08. The 530 added to the lesser value will give us the greater value. So if you're in doubt, you can think about it that way, but that should be our second equation. To show this a little bit of a different way, I'm going to go ahead and multiply this whole equation by 100 to go ahead and get rid of all the decimals. So if I multiply this equation by 100, I'll get 11x equals 8y plus 53,000. From there, I'm going to go ahead and take this. I notice that this equation is more in standard form, our first equation. This equation is not really in standard form. So I'm going to take and I'm going to put this in standard form by subtracting 8y from both sides. So I'll get 11x minus 8y equals our 53,000. Great. So I'm going to take that, I'm going to put it up here at the top. 11x minus 8y is equal to 53,000. And I'm going to take our first equation here, I'm going to line it up underneath, but as I do so, I'm going to multiply by 8 to eliminate the y's. So that would give me 8x plus 8y equals 80,000. Great. Now my system is set up to eliminate the y's. If I add 11x and 8x, I get 19x. And if I add 53,000 and 80,000, I get 133,000. I'll divide both sides by 19, and x is 7,000. So, good. We can go back to our original equation that x plus y is 10,000. So if x is 7,000, we'll plug that in, plus y equals 10,000. And of course, that means y is 3,000. So let's answer our question. Gina invested $7,000 at 11% and $3,000 at 8%. Thanks again for joining us for this other edition of Systems of Equations Applications, where we looked at percentages and investments.